Hey guys, and welcome back to another video on the channel. In today's video we're going to be pretty much going over an introduction to Ohm's law and how to solve circuit problems using Ohm's law. So Ohm's law is pretty much just given here. So if I just switch to a black pen so you can see it. So V equals IR, that's about it. So what V stands for is the voltage. So voltage, that's A, L, voltage, I is current, and R is resistance. Okay, so the units for each of these you'll probably need to know. So voltage is given in volts, which is just usually just as a V. Current is given in amps, but that's usually given with a capital A, and resistance is given in ohms. So if you see this funny symbol, this is pretty much what ohms means. Okay. From looking at this formula, we can see voltage is the product of both current and resistance. So what that pretty much means is if your voltage increases, then your current's going to increase. Okay? If like your resistance is kept constant. So for example, let's just say the resistance in a circuit is kept constant and I increase the voltage, I'm going to increase my current pretty much. Okay? Now, if we kept voltage as a constant, so if voltage was constant, and I increased my resistance, my current is going to go down because you can see they're both a product. So if this stays the same and I increase this number has to increase because when you multiply them together, they have to be equal to that pretty much. Okay. So voltage is proportional to resistance and current most of the time, but any other way, it's pretty much inverse proportional to one another. Okay. Other ways you'll see this formula is pretty much, alright, you might have resistance equals voltage on current, or you might have current is voltage on resistance. Those are other ways you can see that formula, but they're pretty much the exact same thing, just rearranged algebraically. So now that we've got most of this out of the way, let's just put this stuff into practice and work out how to solve basic circuit problems using this formula here, okay? Actually, before we do that, we should probably know what series and parallel circuits look like. So let's just go to the next slide, which I think is series first. Yeah. So series is pretty much, if you have a circuit in series, it will look something like this. And what we need to work out is how to calculate the total resistance in that circuit, okay? So figure 1 shows 3 resistors connected in series so that any change flowing from A to B, so A to B, so A is here and B is here, must pass through each in turn. This effect simply adds the individual resistors to create a total of all 3. It is the same as increasing the effective length of a single resistor. So pretty much, if you want the total resistance in this region here, you just add each of them up if they're in series. So that's what this formula here means. Another way to rewrite that is pretty much, so what this is saying is R total. So R total would be resistance 1 plus resistance 2 plus resistance 3, and that's how you would work out that total resistance if it was given in series. Let's just go on to parallel now. So you can also have a resistors in parallel, which is seen as below. So if you want to work out the total resistance here, it's a bit funny because you have to go 1 over. So in total, if you want the resistance total, you have to work out 1 over first. So 1 over the resistance total. So if you want to work out the total resistance here, you go 1 over is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay. Once you rearrange that, you're going to get 1 over R total is equal to, say, some number here. So let's just say this was 1 on 6. Okay. So that means my R total, I would flip this and go R total would be 6 ohms pretty much. Okay. So you must add up the reciprocal. So a bit of mathematics here. We're going to have to pretty much make them all have common denominators to add them together. So adding them up in parallel is a little bit trickier, but still doable. Okay. And that's about it pretty much for this stuff here. So this is an example of it in parallel. This is an example of it in series, and this is the formula for Ohm's law. So let's just get straight into some problems straight away. So the resistance of a torch bulb drawing has 2 amps of a current at 12 volts. Okay, so we're pretty much solving for resistance. So all we do is write the formula. So voltage is current times resistance. So what we've been given is current, because remember that's the units for it in amps. So I is 2.0 amps. And we don't know what resistance is, but we have been given volts. So V is 12. So if I were to plug this stuff into our formula at the moment, I would replace wherever the V is with the 12, and wherever there was an I, I'd put the 2 pretty much. So it's going to be 12 equals 2.0 times R. Now, if we want to work out what R is, we need to get rid of this 2. So what we got to do is divide by 2 on both sides. So R is going to be 12 over 2, which is 6. And we're going to put this here for its unit, so it's in ohms, okay? So out of A, B, and C, we can see it's B, pretty much. And that's all you would have to do for that one, okay? Right. Determine the resistance of a car headlight if 1.5 amps flows when 12 volts is applied to it. Okay, so it's a very similar situation. So Ohm's law, V equals IR. We're trying to find R again. So we've been given current, which is 1.5 amps. And we've also been given voltage. So voltage is 12 volts again. Okay. Now, we're probably not going to get a whole nice number, mainly because of the decimal thing you have here. But in problems like this, you have to be comfortable with having some decimal numbers most of the time. So plug this stuff into the formula. So V is going to be 12, I is 1.5, and we see we have R still here. So if we want to get R by itself, you need to divide by 1.5. So therefore R is going to be 12 divided by 1.5 in this case here, right? So you'd plug that into your calculator, so 12 divided by 1.5, and that's going to give you 8. Now don't forget the units here, ohms. And that's it, pretty much. If you have any questions about these first two questions, leave some in the comments and I'll try my best to answer them, alright? Right, let's go down to the next question. Alright, so calculate the voltage across a torch bulb of a resistance of 24 ohms when 250 milliamps is flowing. Now, this one's a bit different, mainly because we're finding volts, but we've also been given a prefix here. So 250 milliamps, you can't plug that into the formula right yet because of this prefix. This means, so milli means 10 to the minus 3. So this is pretty much scientific notation. So pretty much what we have for current is 250 times 10 to the minus 3 amps. So if we were to think about it, if we had 0.01, if we were to write that in scientific notation, you need to write it like this. You know, move the decimal place back 2. So we could rewrite this as 1 times 10, and since it's going backwards, it's going to be 10 to the minus 2. Okay? So we have it in this form up here. You can leave it like this, or you can put it in decimal form like this. Either one's fine, because you're going to pretty much plug it into the calculator when dealing with small numbers like this. So that's what you would do for current. So you wouldn't plug in 250, you would plug in 250 times 10 to the minus 3. Resistance we've been given is 24 ohms. And we got to pretty much write Ohm's law. So V equals IR. Now we don't need to rearrange everything because we already have V by itself. So all we've got to do is plug into our formula. So plug in 250 times 10 to the minus 3 times by 24. So plug that into your calculator. So go 250 times 10 to the minus 3 times by 24, and it should give you 6. And the units is volts. Okay, and that's the voltage for this question here. Okay, right. Let's go on to the next one. So 3 resistors are connected in parallel. They have a resistance of 3 ohms, 6 ohms, and 9 ohms. Calculate the total combined resistance. Okay, so this one's not really using Ohm's law. It's kind of practicing the stuff we've mentioned up here. So calculating the total resistance in parallel. So the total resistance in parallel, we've got pretty much 3 resistances. So resistance 1 is 3 ohms. Resistance 2 is 6 ohms. And resistance 3 is 9 ohms. So if you want to visualize what this looks like, just imagine some circuit and it's connected pretty much in parallel. So you have one here, you have one here, and you have one here. So for example, this might be the 3 ohms here, this might be the 6 ohms, and this might here be the 9 ohms. So we want to work out the total resistance. If the current's going this way, what the pretty much resistance of this entire thing is. So let's move that out of the way. The total resistance is going to be, remember, 1 over. So 1 over R total in this case here will be 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R total is what we're trying to find. And now we pretty much plug in these numbers into here. So we're going to have 1 over 3 plus 1 over 6 plus 1 over 9. Okay, so let's make this a bit smaller so I have enough room to write. And move this up there. So we've got to pretty much add these together. Now you can only add fractions together if they have common denominators. Now luckily we can see they're all pretty much multiples of 3, so it's not going to be too tricky. So in order to add these two together, I need to make these numbers the same. Now the way I can do that is I can actually change the first fraction, because if I multiply 3 by 2, that's going to turn into 6. So you multiply the bottom by 2 and the top by 2, because technically you're timesing by 1 then. So in other words, you can write 1 over 3 as the same as 2 over 6. So you have 2 over 6 plus 1 over 6 plus 1 over 9. You can add those two together and you'll get 3 over 6. Okay? So now we can get rid of that because we know what that is. That's 3 over 6. Now you've got to add these two together. Now, there's no really way you can make this into 9 without multiplying by a funny number. So when you get this situation where you can't turn the 6 into a 9 or the 9 into a 6, pretty much got to find the number that they're both, what's it called, the highest common factor. So what I can think of is 18. So if I times that number by 3 and that number by 3, that turns into 18. And if I times this number by 2 and this number by 2, that turns into 18 as well. So at the top here I'm going to have 9 over 18 plus 2 over 18. Then you can add them together, so you're going to get 11 on 18. So once we've done all that little mathematics, we get 11 on 18 is 1 over the total resistance. So now we've got to get the total resistance as the subject. So pretty much we're going to flip it. So if you flip this the other way, you're going to have the total resistance divided by 1, which is itself. And now we've also got to flip the right hand side here. So you'll have 18 over 11 is your total resistance. So that'll be how many ohms it is. If you wanted to work out the actual number, plug that into your calculator. So you've got 18 divided by 11. And that should give you about 1.63 ohms. Okay, so that'll be the total resistance over this circuit if they're connected in parallel. Okay, if it was in series, you would just add them together, but they've said parallel, so this is the correct working for it. All right. Righto, so let's combine these ideas together. So let's combine this idea about series and parallel, and as well as Ohm's law, into an actual circuit problem. So here we've got a circuit. Calculate the current for this circuit. Okay, so we've got a couple things going along here. So we've got voltage at the moment. So voltage is 12 volts, and we've also got two bits of resistance connected in parallel here. So what we're going to do is work out the total resistance here. So the total resistance here will be 1 over R total, and it will be 1 plus R2 plus 1 over R3. Both of them are 10, so that's going to be pretty good at the moment. So 1 over R total is going to be 1 over 10 plus 1 over 10. So that's just going to be 2 over 10. So in other words, it's going to be 1 over 5. Okay, so 1 over 5 is 1 over the total resistance. So if you were to flip this around, R total is going to be 5 ohms. Okay, so that's for this region here. So we're just going to write that there. That's going to be 5 ohms. Right. So we've got that. We're trying to find current, so let's just write down Ohm's law real quick. So V equals IR. We need the resistance for the total circuit. So now we've worked at that. We've got pretty much two, if you think about two bits of resistance in series, because we've got R here, and we've worked out this total thing to be 5 ohms. So the total resistance now. So now I'm going to rub out this working because I don't need it anymore. The total resistance going along here, when the current goes through here, it's going to go through 5, and then it's going to go through 20. They haven't really specified which one's positive or negative. It could be going the other way actually. I think that's positive, so conventional current's probably going that way, my mistake. So if I rub that out, it's going through here, so it's going to go 20 ohms as resistance, then it's going to go through this entire thing and get rid of 5 ohms, and then go back through here. So the total resistance will pretty much be this number added with this one, because you can think about it, they're both in series, because this entire thing is just like one big resistor. So R total is going to be 20 plus 5, so R total is 25 ohms. So that is the total resistance for the entire circuit pretty much, okay? So now I'm going to rub all this out. What this is saying, this is pretty much an amp reader. So for example, this would read pretty much the amps, and this here would read the voltage pretty much there. That's not really specific to our problem here. I've just kind of copy and pasted and made this specific question, okay? So we've got R, so R is 25 ohms, and voltage is 12 volts. So now we've got to plug it into Ohm's law. So we're going to have 12 equals I times by 25. Then I've got to get I by itself, so divide by 25. So I is going to be 12 divided by 25. And if you plug that in your calculator, that's going to give you roughly 0.48 amps. Okay? And that's how you would calculate the current for this particular circuit. Okay? Let's go to the next problem. So calculate the current. Sorry, I didn't read it properly. Calculate the current for this circuit. Okay, so this one's a bit better. They've actually got it labeled. So the current is going to be going through this way. This is conventional current, and it'll be going through a couple things. Now, this one looks a bit trickier than the previous one because we've pretty much got 2 of these in parallel. So pretty much we're going to do 2 separate calculations. So we have to work out the R total here and the R total here. And then pretty much the entire total of the circuit will be this plus that, okay? So let's just label our things at the moment. So let's say this is section 1 and let's say this is section 2. So section 1, it's going to be 1 over R total will be equal to 1 over R3 plus 1 over R4 because they're in parallel. So 1 over R total here will be 1 over 10 plus 1 over 10. You can add them together because they have common denominators, so you're going to have 2 on 10, which hence is going to be 1 on 5. So 1 on 5 is equal to 1 over R total. Then what you're going to do is you're going to flip your fraction, so you can turn these guys around as long as you turn this one around as well. So R total will be 5 ohms for this section here. So that entire section here I can rewrite as just 5 ohms, and that's that one done. Okay, so that would be the working. You would need to work out the total resistance there. Now we're going to rub this out, and we're going to do the same thing for section 2. So rub this out. And now for section 2. So section 2, they're both in parallel, so it's going to be the 1 over R total will be 1 over R1 plus 1 over R2. Now they're both actually the same numbers, so we're actually probably going to get the same resistance. So R on total is equal to 1 on 10 plus 1 on 10. So you get 2 on 10, so that's going to be 1 on 5 is equal to 1 over R total. So what that means is R total is 5 ohms. Okay? So I can rewrite that whole thing, that entire bit there, as just 5 ohms. Righto. So what I'm going to do is redraw this diagram, because we can actually technically update it because we've worked out the total resistance in those sections there. So when you think about it, our circuit actually looks like this now. Well, not looks like, but it will have the same pretty much rules applied. We've got pretty much just 5 ohms here, 5 ohms here, and 5 ohms here. So technically they're in series. So if we want to work out the total resistance, you just add up this with that with that. So it's going to be 5 plus 5 plus 5, which is 15 ohms. So 15 ohms is the total resistance of this entire circuit here. Now that took a bit of working, but the best thing to do when doing something like this is just take your time with it and label the sections you're working out. So that is the total resistance for the entire circuit. So I'm just going to move that stuff together and then move that up there. So we haven't even answered the question yet because we're trying to find the current for this circuit. So let's just copy this, get rid of that. So we've also been given the voltage is 15 volts. So Ohm's law is VIR. You have that and you have that. We've got to find I. So plug in V, which is 15, equals R, which is 15. So you're going to have 15I. Divide by 15. So the current is 1 amp. Okay, that's it. Righto. If you have any questions about this particular circuit, leave some in the comments and I'll try my best to answer them. But let's get down to the last question of the video. So that's probably the hardest circuit I think I've put in here. Let's go to more of an easier one. So calculate the current for this circuit here. So voltage is 10 volts, and now we've got to work out the total resistance here. So you can see they're in parallel again. So 1 over the total resistance will be 1 over 8 plus 1 over 6. Okay. Now we can see there's no really easy way to make them the same number. So what we've got to do is kind of think of a number that pretty much they both have in common really. So I can multiply this by 3 to turn it into 24, and I can multiply this number by 4 to turn it into 24. So 1 over R total, because the reason why we need them the same number is because we can't add them together unless they have a common denominator. So if I multiply 1 on 8, the top and the bottom, by 3, and I multiply the top and bottom of 1 on 6 by 4, what I'm going to get is 3 over 24 plus 4 over 24. So the reason why that's good is because I can add them together because they have a common denominator of 24. So 1 over the total resistance is going to be 7 over 24. So now we've got to do is flip these and flip these. So you get R total is 24 on 7. So if you wanted that as a decimal number, put that in your calculator. So 24 divided by 7 gives you 3.42 ohms is your total resistance. Okay. So now we know R is 3.42 ohms. And now we can use Ohm's law to work out the current for this circuit. Okay, so let's rub this out. So V equals IR. So we're going to have 10 equals 3.42 times by I. Divide by 3.42. 3.42. So I is going to be 10 over 3.42. So plug that into your calculator. So go 10 divided by 3.42, and it should give you 2.92 amps. And that's it. Righto. If you have any questions about the stuff we've covered in this video, try and leave some in the comments and I'll try my best to answer them. And if you want, I could probably do a follow-up video to this stuff here, because this is probably the basics of Ohm's law, doing basic problems like this and then applying it to a circuit like this, which is a bit more complicated because you've got to use the series and parallels. But anyway, I hope you enjoyed the video.